Hey, hi everyone. We are here to learn application development on the iPhone and iPad. Before going in detail for the application development on this beautiful platform, let's start some general discussion so that we know what we are here for. Why we use software? That's the first question I always ask, to myself. Why I use software? Why I want to create a software? As a layman, a client comes to you and say, I want to develop a software. So what is the purpose of creating a software? Someone might say, everyone might say, it's just an automation of some real world task or some day-to-day task which you want to optimize or automate it. So a software I define as a virtualization of some real world entity or some real world scenario, and we develop an ecosystem across it. So if a software is a representation of the real world task, it should handle all the complexity of the real world. So when we design a software, we need to know that, okay, I want to design a software which handles all my complexity which I encounter in my real life. That's the one thing. Now let's focus our discussion on one more scenario. I give you two apartments, one apartment, and both the apartments are in the same locality. We are furnished with the same facility. Everything you find in, say, apartment A, we will see in apartment B. The only difference in the apartment is that apartment A has only 4 walls and it has everything scattered, whereas apartment B has everything compartmentalized. So you can find a living room, a bedroom, a washroom, kitchen, everything get compartmentalized. I want to ask you one simple question. Which apartment you want to choose? It has same facility, everything is same locality. I say most of us, 95% of people we want to say, or almost everyone we want to say, I want to use apartment B. The question comes, why? Why apartment B over apartment A? Everyone says, we say, it's more organized, it's more categorized. I know where everything exists and where everything is lying. So in the real world, we need everything to be organized or everything needs to be categorized. Today, whenever we interact with any single thing, whether it's a living being or non-living thing, we start categorizing it and then we start saying it, oh, I would expect to have in this state, this behavior. Exactly. So when we say we are representing anything in the real world to software, we have to think that way. So this gives a rise. So I would say Objective-C or any object-oriented programming language is towards the apartment B concept, whereas the conventional C language is towards the apartment A. I'm not saying C is not used. It's normally used towards the OS level or to the procedure level of thing, whereas when we create an application which needs to interact with the user, it's more towards the application level layer of the software. So I would say it needs to be more towards the object-oriented approach. So we say we have to switch to the object-oriented concept when we say I want to develop a software for interacting with the user. And now come back to why we have taken this discussion is that when we want to develop the application for the iPhone, iPad, it's basically a user interface. You might have a great backend, but if your user interface is complex, you might say, I don't want to use this software. Let's take some simple software which is easy to use. So a software success and a failure purely depends upon the user interactivity. If your user interaction is marvelous, you want to say your software is pretty good. Yeah, backend is required, but the user, your end user will interact with your front end. And when you develop a software for the iPhone and iPad, it's basically meant for the front end. Now, I won't say an Apple are always the innovators, but I will always say they are most perfectionist. They are perfect. They want to take anything from the real world or current scenario and gonna perfect to such a level, and we're gonna say wow. So throughout this course, we're gonna see what's the wow factor in Objective-C. Is an object-oriented language like C, Java, C++, Java, but why Objective-C has a wow factor. So throughout this course of the Objective-C, we're gonna see the wow factor. We're gonna compare normal object-oriented programming language and see how Apple have added a wow factor and say, oh wow, you know. And please, when you start developing the applications for the iPhone and iPad, I would say you have to take one big thing into consideration about the Apple USB. They want the user experience to be at a peak. So when you develop a software or any application or game, make sure your user interactivity is at the apex. No negotiation needs to be done on that. Now let's having the brief review of what we want, what the softwares are, what we have a clear idea right now. And before moving to the objective C, I want you guys to let's note down some concept which comes to our head or we have learned during our school or graduation days. When I say programming language, whether it's an object-oriented or procedure-oriented, what all terms comes to our mind? And let's start noting down and let's see how they came into existence and what are the purpose of these terms. Why we are using these terms in a programming language. Because on the first sentence I told you, softwares are nothing but the replication of a real world. So when we create a software, we have to replicate the terms from the real world. And then your thinking gets better and better and you will come up with a software which exactly replicate the real world scenario. And then you can say, oh wow, then your software is towards the complexity. Okay, now we're gonna start with some terminologies which come to our mind when we say programming language. So when someone says, you know programming language, or someone say, I know programming language. So what are terms comes to our mind? Like anything, whether it's object-oriented programming language terminologies or the procedure-oriented. I will start jotting down some terminology which comes to our mind when we say programming language. So let's say object, everyone? Yeah. Class, functions, or methods in terms of object-oriented programming language, variables, encapsulation, inheritance, polymorphism, pointers, static, access specifiers, constructor, destructor. What else? What else comes to your mind when we say programming language? You can say, so we can say interface in terms of Java. So this all comes to your mind when we say programming language. Now, all of these terms, most of them are towards the object-oriented concept, whereas few you can find in C, mostly pointers, variables. Now, before we start seeing the real map of how this term is mapped towards the real world, we will start why an object-oriented program is called object-oriented. Why a name is not different than object-oriented. So when we say object-oriented programming, what it signifies? Now, when I say human, there is nothing called human. Human is a template and we all are object of human. So the real world doesn't run on the templates. We are the objects who runs the real ecosystem. You can take anything around you, whether it's a living being or non-living being. Say a water bottle. It is an object, right? So a water bottle can be of any type, but the object are the key players in the real ecosystem. God. There is nothing called God, right? Superhuman being. Some people who comes in that category, we say God. Oh, you perform this type of, so categorization is there. So it's the real world is object oriented. So the software which we going to replicate the real world should be object oriented. Therefore, the name object oriented programming language. So in real world, the emphasis is always on object. So as we know, object is the main entity. Now look at a cell for anything around. It's an object. So an object has an appearance which we call state, and the purpose why the object is inside the ecosystem, we call it behavior. So everything has a physical appearance, and which we call the object in that state. So when you're smiling in jolly mood, you say he is happy. When you are in a sad mood or you have your face down, you will say he is sad. He is sad. So object has state and a behavior. The purpose why an object is in the ecosystem. So we say an object has, say, state and behavior. Now, in terms of programming language, what do you represent state as? So a state as is represented by the variables. Say a student have a state called roll number, name, standard, specialization or subjects. So this all will be an object. Student will have this many states. Oh, so a student going to 5th class, we're gonna say his state is 5th. The behavior. Now the behavior is represented by the methods. The purpose of a student. Student goes to the school for studying, he have to do homework, he have to complete his assignment, he have to be a part of, say, extracurricular activities, and say he have to learn Objective C. So what is the behavior? We say it's a methods. So one can say a class variable, a class member are the state of an object, whereas the member function, or we say methods in object oriented language, the behavior of an object. So the purpose is always represented by the behavior, and the appearance is represented by the state. Now let's take the example of you and me. Today I am teaching or sharing my knowledge about the Objective-C to you. Therefore I am standing in front of the blackboard. So my state is standing, whereas you are sitting in front of a monitor and you are listening to my lecture, and therefore the purpose of you is to grab the knowledge from me about the Objective-C. Therefore your state is sitting. So depending upon your behavior, your state change, and then with the state change, it reflects your appearance. So basically your methods are running on the state. They update state depending upon your influence. So now function is a terminology in a procedure oriented language where we say you have to do this, after this. But whereas method is inside yourself. So no one can influence. You are responsible for your own life. So people might say, oh, let's try this. It's you who have decided whether I want to do that or not. So your method influence, your behavior influence your state and your appearance. Now once we are done with the object, variables and the methods, let's concentrate on the class. Now as I told you before, class are just a template. In order to categorize things, human is a class. Whereas the key players of the humans, say we, you and me, are object which runs the ecosystem. So a class is basically a template where the key players or the players in the ecosystem can be categorized into. So class is just a template. He is not an active player in the ecosystem. Therefore, the name is never called as class-oriented programming language, whereas it's always called object-oriented programming language. So people might say, I'm writing code inside the class. It's just a template. You're writing your code. The one who executes it, it's an object. During the runtime, the object is the one who gets affected by your code. Now let's come to a concept called encapsulation. Now, when I say encapsulation, it's everything within yourself. Now, your state, your behavior influence your state. So everything is within yourself. So a player or the object which runs the ecosystem is everything within yourself. Therefore, we say it's capsule. Your state and your behavior is capsule. Therefore, a term called encapsulation. Now, after we have done encapsulation, it's time for inheritance. Now, what is inheritance? How is it related to the real world? So, I told you, whenever we interact with any object in the real world, we start categorizing. Oh, he belongs to this state. Oh, he belongs to this religion. He belongs to this caste. Oh, I might expect him to be sensitive on this topics, whereas he will be bold on these topics. So, we start categorizing everything we communicate, whether it's a living being or non-living being. Every object which we communicate, we categorize. Now, how does this categorization comes into picture? So, if I want to have a tree structure, oh, this object belongs to this, there should be a concept replicating in a computer language. So, it's say inheritance. So, inheritance, everyone, the common definition everyone says, generalization to specialization. So, you can say you're a graduate. A graduate is invited in a party. So, it's a general term. In that party, even a commerce graduate can enter, or a doctor can also be a part of it, or an engineer, etc. So, inheritance helps you to categorize. It's the most important terminology in the real world, categorization. We interact with the object depending upon the categorization of which subclass it belongs to. So, it's inheritance the most important concept. So, we are not going into detail of types of inheritance. Everyone knows what the types of inheritance is. So, with inheritance coming into picture, there are many complexities added to your system. Now, say, one of the complexity is polymorphism. Now, when I say polymorphism, some things comes to our mind. What are these? Yeah, exactly. Function overloading, function overriding. Now, polymorphism means many forms. Poly means many. So, many. I never say anyone is right or wrong. It's like his point of view. He might think thing A is right, whereas my point of view might say thing A is wrong. So there's nothing called right and wrong in the real world. It's just your point of view, many point of view. So anything which has multiple point of view is polymorphism. So in the real world, when we have this type of this type of feature where people might have different point of view on the same thing, that same thing needs to be reflected in your programming language so that your software has that complexity to handle. So first we're going to look at function overloading. Now, function overloading is nothing to do with inheritance. It's like within yourself. Now, say your teacher enters the classroom. She is in very good mood and she might say, please open your books and start performing your assignment. You might think, wow, she's in a good mood, let's get all pending assignments checked today itself so that everything gets cleared out right away. Say next day, teacher comes into your class and she has a rough day while coming to the school. So she just shouts at you, please open your book and start doing your assignment. So the same message made differently at a different context. Yes, the day one message was very polite and you decided to get your assignment checked, whereas the next day the same message means arrogant. It was more showing the anger, or you can say a bad mood of your teacher. You decided, I won't show her assignment else I will be in trouble. So same message, or I say same function call being said to the being received to the object means different in a different context. Because when you have such requirement in your software, you have to adopt function overloading. A lot of people have a wrong concept of it. It says it reduces my name conventions. So if I have 100 functions and I have same function, I can reduce the name with a different argument. That's a wrong concept. Where we can say when you have same method might react to a different situation, we say function overloading. Now say a same message means different in different context. That's a normal way we always say, oh, you should say this way. It would have been differently. The same thing, different context. So your argument to the function or the method are the context. So different arguments are what? State of an object, right? So it says different argument to the same function is called function overloading. So when you have such situation where a same message might mean different and in a different context, you have to implement function overloading in your class. So that particularly means function overloading. Now let's come back to something called function overriding. Now function overriding has nothing to do within yourself. It's something to do with the hierarchical structure in which you belong to. Now let's say a parent tells us to do, oh please perform this task. You might say someday, I will perform this task but in a different way. So same point of view but executed differently by a different player. Now some people might say it's a generation gap. It's a day-to-day task, day-to-day thing which we come across. So a derived class might say I want to perform this task but I will perform my way. It's my way, my point of view. Where the base class say I will perform this task with my point of view. So same thing, same point of view within the hierarchical structure, and they have a different point of view by different players in the hierarchical structure. We say we have to implement function overriding. So when we say function overriding, it means say different point of views for same message by different players in the same hierarchy. So if you have such situation, you have to go for the function overriding. Now let's come down to pointers. Now pointers will be doing later on when we want to see the wow factor with the properties later during the session. So pointers are the most important component in memory management. We want to see how pointers are related to the real world. Now comes static. The word static. Now something which is at a class level, we say static. Say a student or the college or the school says student have to wear such uniform. Say a white shirt and white pant with a blue tie, red tie, yellow tie, depending upon the house where it belong to. So each object, student object, have to wear the uniform with the way it's been prescribed for the students. So something at a class level which each and every object has to follow, we say it should be static. So a static means applied to all the objects belonging to that class. So when you have such requirement, you have to say some static. Now we got to concentrate on a term called access specifiers. Now when we say access specifiers, some terms come to your mind. It's called private, protected, public. Now what it means? Everyone has secret which they want to keep within themselves. Only your own members or all your behavior can influence them. So we say such things should be private to yourself. So whenever you have certain things which need to be private to an object, we say declare them private, which can be accessed only within the object itself. Protected, some information we share to a protected environment, and when we share them, we say them. Please keep it to yourself and do not share it everywhere. So the terminology when we say protected thing, protected state or the behavior of an base class becomes the private of the derived class. It means that. But in a real world, it's not always that scenario. A protected thing in a base can become a derived of the derived class. So we can say protected. So basically, we can say that a real world is not exactly replicated by the software world, but the bridging is being done by the object-oriented programming language. So it's trying to fill the gap between the real world and the programming world. When we say public, something like your Facebook ID, it's public, everyone knows it. So the access specifiers define the scope through which you want to spread or you want to stand your information. So something which is private will remain within the boundary of yourself, whereas protected will be in the boundary of a protected environment, whereas public will be open to entire ecosystem. So when you plan something, a class, you have to define the access specifiers. Let's see what we call constructor and destructor. So we're gonna see constructor and destructor when we're gonna see Objective-C language. Interface. Now interface is something related to Java language. It's a very beautiful concept, and we see how this concept is leveraged in the Objective-C. When we're gonna start with Objective-C, and we're gonna see how all the terms which we have noted down of object-oriented programming language, how are they treated in Objective-C, and how the wow factor has been added to make the life more perfect.